All right, now we're going to talk about subnetting networks. To do subnetting, we have to understand a little bit about binary and how computers work with binary and how we can convert decimal numbers to binary and binary numbers to decimal, etc. This is one of the foundations of subnetting. We use subnetting quite often when designing networks. Subnetting allows us to break up one big network into a bunch of smaller networks. This can improve network performance, keep things organized. It can be used as part of our security. So we separate traffic from one network from another network. We use subnetting all the time. So far in the previous labs, anytime we've applied an IP address, we've also had to apply a subnet mask. Today, we're really going to dig into that subnet mask and figure out what those 255.255.255.0s really mean. Now, this video will not be enough to understand everything about subnetting. Reading in the textbook, reading sources online, watching other YouTube videos might be extremely helpful. My experience shows that it takes a couple of days for subnetting to really sink in, even if you're familiar with the terms and concepts. It's just something that takes some time, takes some experience working with it until it clicks. And then once it clicks, you'll wonder why you ever thought subnetting was difficult at all. So let's start with binary. We know that we're most familiar with decimal numbers. So base 10. We got the ones place, we got the tens place, hundreds place. These are regular integers. It's how kids learn to count. Decimal, it's coming from dec, 10. We basically have the system because we have 10 fingers, and people a long time ago found that it was really convenient to count to 10 because they could count on their fingers. Well, computers don't work that way. Computers like binary. In binary notation, you can have two different digits, 0 and 1, so base 2. Imagine if computers had just two fingers and that's what they could use to count with, that's what they would be using. Now every number can be represented in decimal or binary. We tend to like binary, computers like decimal. Let's see how they can work together. Here's an example of a table converting between binary and decimal. In the lab, I want you to go through this process. We've got our binary representation, we've got our decimal representation. Let's format column A. Format cells as text 00110111. So decimal, I've given that one to you. It's 55. Okay. What if we wanted to calculate that? And I'll let you cheat. Let's bring up the Windows calculator. Now there are different modes that the calculator can be put in. Let's go to Programmer. Right now, decimal is selected, so if I type 55 in there, I can type in that decimal number, and the Windows calculator is automatically going to give me the binary representation of that number. So in binary, 55 is 00110111. What if I want to go the other way? What if I have a binary number like this? 11111111, and I want the decimal representation. Well, I can clear this out, just hit the escape key. I'm going to put in 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I chose 8 because our IP version 4 addresses have 8 octets. That's 8 binary digits. Same thing with our subnet mask. There are 8 of these separated by periods. So if we have all ones, our binary is 1111111. The decimal representation is 255. So that's an important one to pay attention to. This is one you should have memorized. 8 ones equals 255. You'll use that one quite a bit when creating, excuse me, when creating subnets. Okay, how about binary? All zeros. Well, that's an easy one. Can you take a guess what the decimal is? I don't even know if we have to type it out, but you just start typing zeros. The calculator doesn't even add any zeros because there are no values there. The decimal equivalent is just 0. Okay, how about the decimal 192? So to convert that to binary, I'm going to click decimal in my calculator, type 192, and here we've got 1 1 followed by 6 zeros. All right, how about 32? Let's just keep going. 32 is 0 0 1 0 0 0 0 0. Fill that out to the 8th one. All right, 240. 4 ones followed by 4 zeros. Good. So how about, what if we're given a binary 5 ones followed by 3 zeros? Let's take a look at what that would look like. So I select a binary, 1 2 3 4 5, 1 2 3. The decimal is 248. 2 3 4 5, 1 2 3, 248. I've got 7 ones. 1 2 3 4 5 6 7, followed by 0. That would be 254. And last one, clear that out with the escape key. 1 0 1 0 1 0 1 0. The decimal is 170. So again, to convert between binary and decimal, it's easiest just to use the Windows calculator. It's good to know a couple of these just off the top of your head. Know that 8 ones means 255. 2 ones followed by 0, 6 zeros is 192. That's an important one. What would 1, 3, 4, 5, 6, 7 be? Here's a little extra credit. This is one we'll use quite a bit in subnetting. 1, 1, 2, 3, 4, 5, 6, 7. Okay, it's 128. All right, so where does this come from? So we've used the Windows calculator to convert between the two, but what is the Windows calculator doing behind the scenes? Let's dig into that just a little bit. So in binary, we can think of each one of these digits. Each one has a certain place. So it's the 1 place. The 2, 4, 8, 16, 32, 64. It goes up from there. So I'm going to pause the video just for a second to create a table. Okay, so I've created this table here with the place value. I've got 8 columns here, 1, 2, 3, 4, 5, 6, 7, 8. So that represents each of these binary digits here in this octet. So 8, we have our octet here. Think of this as one of the decimal numbers in our IP address or subnet mask. I have a place here for the binary representation of a decimal number. And then below that, I'm going to put the values that are going to be added. So here in binary, we have this number 0, 0, 1, 1, 0, 1, 1, 1. Here's how I can convert that binary number into decimal, if this is a 1 in the column, if the binary is a 1, I will copy its value down to be summed. So I'm not going to copy that because it's a 0. I'm not going to copy that 64 because the binary is a 0. I'm going to copy that 32 and the 16 and the 4 and the 2 and the 1. I have a simple formula here in cell M5 that just sums everything in this summed, labeled sum row. And we see that indeed the sum is 55, just like we got with our decimal with the Windows calculator. So my spreadsheet seems to be working correctly. Let's try another one. What about 1, 1, 1, 1, 0, 0, 0? 1, 1, 1, 1, 0, 0, 0, 0. See 1 here in this column, so I'm going to bring down 128. Same thing with 64, same thing with 32 and 16, but not the rest of them. I see I get a 240 total. Matches what's going on here. So just realize, making this table, going from right to left, the value of the place doubles every time. What if we fill this out with 1s? 8, 4, 2, 1, we get 255. All right, it works. That's a crash course in binary and decimal. So that's good. We need to know a little bit about binary, but let's keep going because things will get a little bit more interesting here. Let's talk about the ways that we can represent a subnet mask. There's a couple of different ways that, I would say 3 main ways to represent subnet masks. We have the dotted decimal notation. This is what we're very familiar with. We've used this in the lab so far. If you're setting your IP address and subnet mask in Windows or Linux, you have to use this dotted decimal notation. I say dotted decimal because we have decimal numbers separated by dots or periods. We also have a CIDR notation. CIDR stands for Classless Interdomain Routing Notation. That's a very big acronym. Nobody ever says that, they just say CIDR. So this CIDR notation, it's always slash something. So this one is /24. 255.255.255.0 and /24 mean the exact same thing. You could use either notation and someone with enough networking knowledge would know what you're talking about. They're not going to wonder what you mean when you say, I'll put it on the /24 network. It means the network with a subnet mask of 255.255.255.0. Now, people in networking, we tend to be lazy, maybe in all of computers. Saying all this big, long dotted decimal notation just takes a long time. It's a lot more syllables than just saying /24. /24 is much easier. But that's just the way it goes. So why is this 24? That may not make a whole lot of sense. What is 255 in decimal notation? Think about it. The answer's on the screen in a couple of different places right now. Well, it's just 8 ones, right? So we can convert this whole number to binary. We have 8 ones, followed by 8 ones, followed by 8 ones, followed by 8 zeros. So count up the number of ones, or if you're super high-level mathematician, you could count them in one of the octets and multiply by 3. How many ones do we have here? Well, we have 24 ones. Happens to match our CIDR notation. The CIDR notation is basically how many ones do we have from left to right in our subnet mask. An important thing to realize about subnet masks, they are always 100% of the time, without fail, going to be a bunch of ones on the left, and then filled in with as many zeros as we need to get to the end of that fourth octet. So the CIDR notation tells me, hey, we've got 24 ones to start off our subnet mask, and then it's going to be followed by 8 zeros, because all IP version 4 addresses will have 32 binary digits. Good. Now over here we have something very closely related. It's a little bit beyond just subnet mask notation, but this asks us what the number of hosts is for this network. Now there's a formula here, 2 to the n minus 2. Now what is that n? That's the tricky part. You can think about it in a couple of ways. Maybe the easiest way to think about it is the number of zeros in our subnet mask. Host space is the address space that we're using for computers, for printers, for servers, laptops, smartphones, all the things that we're connecting to our network. And our subnet mask determines how many of those devices that we can put on that particular network. So here we have 8 zeros in this subnet. That means our n is going to be 8. So we can do this in Excel. Equals 2 to the 8th. Then subtract 2. We get 254 hosts. So why are we subtracting 2? Well, we reserve the very first IP address in that network for the network address, and we reserve the very last IP address in that network for the broadcast address. So that's why we take those two off. So if I use this subnet mask, I can put as many as 254 laptops, printers, smartphones, etc. on that network. So that works out fairly well. Let's see. That first example is done for you. Let's look at the next one. Here I've got 8 ones followed by 24 zeros. So I've got 8 ones, so what's my CIDR notation going to be? I'm going to create a new sheet. Binary, decimal, CIDR, number of hosts. These are all going to be big. I'm going to format these cells as text. Probably don't need to, but I'm going to. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Expand this a bit so it all fits. So the dotted decimal. So I have to convert the octet by octet, each one of those octets into decimal. Well, 8 ones, I know that's 255, right? We should have that one memorized. And all zeros is still 0. So representing that binary subnet mask in dotted decimal is just 255.0.0.0. If I want to be even more efficient, what's my CIDR notation going to be? Well, what do? I count up these ones. 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 ones. So this would be, oops, I've got something selected here. /8. All right, so my number of hosts. What is my n going to be here to calculate the number of hosts? So it's 2 to the n minus 2, but what is n? Well, there are 32 digits here. How many of them are zeros? 24, right? So equals 2 to the 24, then I subtract 2. Holy moly, that's a big number, right? I don't need any decimals here. Wrong way. I can put 16.8 million computers on this network using this subnet mask. So that's a lot. That's actually too many. If we actually put 16.8 million computers on a single network, our network would crash. As a general rule of thumb, 1,000 computers is the most that you want to put on one subnet. So this one, it's basically just too many. It's valid, you could use it, as long as you didn't actually use up all of those IP addresses. All right, let's take a look at the next example. We've got /22. Numlock, that's what's screwing me up. Goodness gracious. Something's screwy with my keyboard right now. I think some of my keys are overridden. It's okay, I can deal with it. /22. Okay, so where do I go from here? Well, so if /22 is my CIDR, I can calculate my number of hosts, right? So I know that there's 32 total digits. 22 of them are ones, so that leaves me 10. 10 zeros at the end. So that's going to be my n. So equals 2 to the 10th minus 2. So that gives me 1,022 computers. So that's using the guide, the general principle of putting no more than 1,000 computers on a subnet. /22 might be a good subnet mask to use. Okay, going right from CIDR to decimal might be tricky. So here's what I'm going to do. I'm going to do my binary first. So I need 22 ones. 1, 2, 3, 4, 5, 6, 7, 8, period. 9, 10, 11, 12, 13, 14, 15, 16, period. 17, 18, 19, 20, 21, 22. So how many ones do I have there? I've got 1, 2, 3, 4, 5, 6. So to fill out that octet, I need 2 more. And then I need 1, 2, 3, 4, 5, 6, 7, 8, just to fill out the end. So just use that CIDR notation, counted out 22 ones, separated them into groups of 8, and I got the binary representation. Okay, so the first octet, that's easy to convert to decimal, that's 255. Second one, that's also easy, 255. Okay, but now we got that tricky third one. I'll use my Windows calculator. 1, 2, 3, oops, escape to clear that out. 1, 2, 3, 4, 5, 6, 0, 0. The decimal is 252. And the last octet should be easy. Okay, so we've got that subnet mask represented 3 different ways. Starting with CIDR, we went to binary first and then converted each of those octets in binary to a decimal format. What if we're given 255.255.255.128? Now, can you do this in your head? Some of you might be able to. Once you start working with subnets, you know what that subnet mask is going to be. How would I convert this to binary? Well, we know 255, right? 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Because that's 255.255.255. Now we need to know what 128 is. So I'm going to click decimal. You know what it is offhand? Think in your head. 128. All right, it's just another 1 followed by a bunch of zeros. A single 1. 1, 2, 3, 4, 5, 6, 7. Okay, so for our CIDR notation, we've got 8, 16, 24, 25, right? So that'd be slash 25. So our number of hosts, that's going to be 2 to the, what am I going to put here? How many zeros do I have in that binary representation? I could do 32 minus my CIDR notation, so 32 minus 25 is 7. And then I subtract 2, 1 for the network address, 1 for the broadcast address. I could put 126 computers on this subnet. Okay, so you should start to notice that there's a relationship. The bigger our subnet mask gets, the fewer computers or hosts we can put on that network. All right, slash 16, let's go through this quick. Slash 16, oh my gosh. I'm having some keyboard issues. Keep hitting the wrong keys. Trying to record this. This one should be easy. We won't need a calculator for this part. 8, 9, 10, 11, 12, 13, 14, 15, 16. Fill the rest in with zeros. Okay, converting this to decimal, easy peasy. 255.255.0.0. No calculator needed. Equals 2 to the, so what do I use here? Think in your mind. What's the number? 2 to the what? Minus 2? 2 to the 16th minus 2. So I could put 65,000 computers on this network, more than I reasonably would want to, but technically that is correct. Okay. So then we're given one here. What if our subnet mask is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1. Now the astute observer would realize that we could cheat and just look up above and figure out what this is going to be. But we know 255.255.255, because those first 3 octets are all ones, we know that's 255. But then what is 1, 0, 0, 0, 0, 0, 0, 0. 1, decimal is 128. What would our CIDR notation here be? Son of a gun. Slash 25 equals 2 to the 7th minus 2. All right. Good. So it's good to be familiar with all these decimal notations. Just know that these subnet masks are always a bunch of ones followed by a bunch of zeros. You will never, ever, at any point, ever see a subnet mask that has a random 0 just stuck in there somewhere. That will never, ever, ever happen. So let's talk about actually subnetting an existing network, where we're going to, let's say we've got the 192.168.1.0/24 network. Okay, so that network, let's just say a hypothetical situation where you have a university network that has a single network with that they can work with. They want to put faculty on one subnetwork. They want to put students on another subnetwork. They want to put administrators on the other network, and student athletes, coaches on another network. So we would want students, faculty, admins, and coaches. So we want each one of them to get a piece of that network. All right. So let's see, hosts. How many hosts are on this total network? 192.168.1.0. So what's our formula? Equals 2 to the n So in here, what's it going to be? 32 minus 24 gives us 8 minus 2. So we have 254 computers possible on this one big network, but now we're going to break that one network apart into 4 equal spots. So what we have to do, remember, when our subnet mask goes up, the number of computers we can support goes down because we're breaking it in half. Essentially, every one that you add to the subnet mask divides the network in half. So let's say hypothetically, this yellow box here represents all of our IP addresses with a /24. Let's put a thick outside border there. This is /24. Goodness, I don't know what's going on with my keyboard. I think the screen recording software has intercepted some of my keys. So this is /24, this whole big yellow box. But let's say, I mean, we said we're not happy with this, right? If we wanted to divide this into 2 equal networks, we could use /25. We use /25 and /25, and that would take that same pool of IP addresses, and it would divide it into 2 equal networks. Okay, but we said we want 4 equal networks, right? Well, to divide that again, we're going to steal from our subnet mask. We're going to divide it again by adding a 1 there. Fix my highlighting. So we've taken one big network that can support 254 hosts. We've just divided it in half and in half again just by changing our subnet mask. And now we want to enumerate these subnets. So we've got our subnet address, subnet mask, first usable IP, last usable IP, and our broadcast address. So how do we enumerate this? This is important. So let's go through it. The subnet address, it's going to be the same starting point that we were given. So we're trying to divide this network into 4 equal subnets. Our first subnet is always just going to start at that address, 192.168.1.0. Now, what subnet mask are we using? We wanted to divide it into, we wanted to take this /24 network and divide it into 4. So instead of using the /24 subnet mask, we are now going to use /26. So, my goodness. Muscle memory is going to prevent me from doing that correctly. So the first usable IP address, this one's easy to calculate. Oh, sorry, mistake there, /26. This is the new subnet mask that we're going to use. The first usable IP address is easy to calculate. We take our subnet address and add 1. So we add 1 to the end here, and we just get 192.168.1.1. Now the tricky part here, the trickiest part of enumerating this is finding the last usable IP address. So how many hosts can I put on this network? This /26 network. So equals 2 to the what? What am I going to put here? Pause the video if you need time to think about it. I'll give you the answer. It's going to be 2 to the 6th. So it's 32 minus 26 is 6, and we subtract 2. we get 62 usable hosts. Now I'm going to add this 62 to my subnet address to get the last usable IP. 192.168.1.62. Now what's my broadcast address? It's going to be the last usable IP address plus 1. 192.168.1.63. So that's that first subnet. Okay, so how do I start my next subnet? I know I need 4. I'm just going to copy these down. This is, hypothetical. So we're going to put students on the first one. So where do I start the next one? Well, I just add 1 to the last broadcast address. 192.168.1.64 is where I'm going to start. Now these are all equal subnets. So I'm going to use the /26 subnet again. I'm going to use it for all of them. I'll just copy and paste it. Okay. First usable IP address, again, that's the subnet address plus 1. 192.168.1.64 plus 1 is 65. Okay, so I know I had, or I remember, we used our formula, 2 to the 6th minus 2 gave us 62 usable IP addresses on the subnet. So 62 plus that subnet address. 62 plus 64 is 126. And my broadcast address is just going to be my last usable IP plus 1. 192.168.1.127. Okay, so I take that 127, I add 1 to get the beginning address of my next network, 192.168.1.128. The first usable IP address is just going to be that subnet address plus 1, 192.168.1.129. I add 62 to that 28. What am I going to get? 192.168.1.190. Yeah, that looks right. 192.168.1.191. I can add by 1 pretty well. So the number that comes after 191, 192, right? 192.168.1.192. First usable IP is just that subnet address plus 1, 192.168.1.193. We're going to add 64. 192.168.1.254 should be correct. So my broadcast address there should be 192.168.1.255. Okay, let's do something real quick here. Previously, what did we have? Before we subdivided anything, we had our subnet address 192.168.1.0. We were given this, the subnet mask of /24. What was the first usable IP address? Well, it's just the subnet address plus 1, 192.168.1.1. Okay, so far, the numbers I've highlighted, they all match. What was the last usable IP address here? Well, what's my number of hosts? Equals 2 to the, what would the n be here? 32 minus 24 minus 2. 254. 192.168.1.254, because I'm adding 254 to 0 there. I shouldn't have hit escape. 192.168.1.254. And my broadcast address is just the last usable IP plus 1. 192.168.1.255. So we had taken this network and just divided it into 4 equal parts. So we use the exact same IP address range. So I'm going to highlight a few numbers here. We'll use orange. See the number, see where these numbers match. Okay. Find something where the contrast isn't too crazy. No purple. How about this reddish? So in our first network, we had a starting network address of 192.168.1.0, a first usable IP address of 192.168.1.1, and the very last usable IP address in this whole range was 192.168.1.254, and the last broadcast address was 192.168.1.255. Those addresses exist when we subdivide it. We've just broken apart that one chunk. So we haven't added any new IP addresses. We've just allocated them to different networks here. Okay? So the start and the end are the same. We've just added some stuff here in the middle to break these into smaller networks. Okay. Now let's do the same thing. I'll start you off on number 2 and number 3 here. So we're given 10.10.0.0/16, and we want 8 equal subnets. Okay, so let's think about it. We have the /16 network. If I add 1 to the subnet mask, that would give us 2 equal subnets. If I add 1, so that's binary, it's not 11, to the subnet mask, that would give us 4 equal subnets. Every time we add a 1 to that subnet mask, we divide it in half. If we add in binary 1, 1, 1 to the subnet mask, that would give us 8 equal subnets. Okay, so let us copy kind of this format here. So we know we need 8 equal subnets, so I need 3 more 1s. I know I have 16 ones there, so my new subnet mask I know is going to be /19. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is going to be trickier to calculate, but it'll be fun. 10.10.0.0. We're just going to start in the same place. First usable IP, it's just the subnet address plus 1. 10.10.0.1. And the last usable IP address. This will be trickier. So how many hosts equals 2 to the what? 32 minus 19 minus 2. Okay, that's a lot. 8,190. So how do I add 8,190 here? Oh gosh, that's trickier, right? You would need some impressive binary skills if you want to do that. It is possible, however, I'm going to show you something. I'm going to bring up Google, and I'm going to Google subnet calculator. So this is a way to cheat. Cheat in a good way. I'm going to scroll down. I like this tunnelsup.com subnet calculator. It's the second result in Google, but I just like it. You can use there's a million subnet calculators on the internet. They all do about the same thing. Here's what I'm going to do. 10.10.0.0/19. I'm going to click calculate. When I click calculate, I scroll down and it tells me a lot of information about this subnet. Alright, this is nice. So it gives me the IP address. That's good. It gives me the subnet mask. It calls it just the net mask. It gives me the CIDR notation. I use that CIDR notation here just because you could use either notation. I've got the network address. That's good. It gives me the usable host range. This is what I'm looking for right now. 10.10.0.1 through, that's what I need, right? 10.10.31.254. I'm glad I did not have to do that binary math in my head or even using the Windows calculator. So what's my broadcast address? The last usable IP plus 1. It's also given to us down here. It's good to know where these numbers come from, though, not just rely on the calculator. Otherwise, you'll get in trouble. Just trust me on that. So what's my next starting subnet address? How do I add one here? Because I know in these octets, the numbers only go up to 255. Well, I'm going to add one here. Makes 0, we carry the 1, so that 31 is going to become 32. 10.10.32.0 is going to be my next starting address. First usable IP is going to be 10.10.32.1. What's my last usable IP? Well, hey, let's come here. We learned a new trick, right? Let's use it. So I'm going to put my new network address here, click calculate. Looks like my usable host name, host range is 10.10.32.1 through 10.10.63, 10.10.63.254. The broadcast address should be fairly easy to calculate from there. So then add 1. My next network is going to start here, 10.10. I'm going to add 1, carry the 1, 64.0. Okay, at this point, you should start to notice a pattern. Really, the only thing that is changing is the third octet here. So you don't have to, unless you want to, you don't have to use the calculator. I know this is going to be 10.10.96.0, 10.10.128.0, 10.10.160.0, 10.10.192.0, 10.10.224.0. I think that's right. Okay, so that's my last one. I'm just adding 32 to that third octet. That's all I'm doing. So here I'm going to be 10.10. Now here for my first usable IP, I'm just going to add 1 from the subnet address. But you know, I mean, if you want to be super lazy, here, not super tremendous, great practice, but copy and paste. Oh, whoops. Hit the F1 key. I don't need your help, Excel. I'm just going to change all those zeros to ones. So pretty, right? There we go. And so my last usable IP address, it's going to be 10.10.95.254. I'm just adding 32 to 63. 10.10.127.254. It's also 1 less than that third octet on the following line. Whatever works for you. 10.10. 159.254, 10.10.191.254, 10.10.223.254, and now 10.10.255.254. All right, so how can we cheat on this last column? It's just the last usable IP address plus 1, right? So we're just going to change all these 254s to 255s. All right, this is perfectly valid. You don't have to calculate all these by hand, but you should know how to calculate all of these by hand. Okay, so the information that we calculated manually, we've got, just notice, okay, I calculated here the number of usable hosts. That does match the number of usable hosts. You may have seen this 8192 and thought I screwed up. Well, this just includes the network address and the broadcast address. Those are not really usable for our purposes. Okay, so we have enumerated that subnet. So let's just do the last one. We'll get you started. Okay. So 32 equals subnets. So 32 is a lot. So how many times do I have to divide that network in half to get to 32? Okay, I'm just going to start typing ones. So that's half, 4, 8, 16, 32. I've got, how many ones do I have there? 1, 2, 3, 4, 5. I've got 5 ones. I started with 25, so I add 5. And that gives me /30. That's my new subnet mask. 1. Okay, I think I got 32 there, so that's a lot. Obviously, that's a lot of subnets that we're going to be enumerating right now. Let's just go through I'll get the process started at least. So what's our subnet address? We are going to start at the same spot. Doesn't really matter where we start. First usable IP address, what's that going to be? Think about it, should know the answer. 22.35.87.129. We're going to do this part manually. What's my last usable IP address? So how many hosts can I support? Equals 2 to the what? 32 minus 30 is 2 minus 2. Okay, that's not a whole lot of usable IP addresses. That's okay, it's perfectly valid. So my beginning network address was 22.35.87.128. So I'm going to add 2. I get 130. My broadcast address will be 22.35.87. I'm just going to add 1 to my last usable IP address, 131. My next address is going to start at 22.35.87.131. My last broadcast address plus 1 is 132, right? First usable IP is going to be 22.35.87.132 plus 1 is 133. And now 2 plus 132 is 134. 22.35.87.134. Should start to see a pattern emerging. 22.35.87.135. Okay, these numbers are completely contiguous. So 128, 129, 130, 131, 132, 133, 134, 135. Just following that pattern alone, you could fill out this entire table. Or you can go down the line, you can see that all we're doing is adding 4 to the last octet. So I know this one's going to start 22.35.87.136, 22.35.87.140, 144, etc., etc. 22.35.87.137, 22.35.87.161, whoops, 141. I need to get my cursor out of the way so I can see my numbers. 22.35.87.138, 22.35.87.142. You could go down the whole column this way. 22.35.87.139, 22.35.87.143. So really, it's just following the same pattern to make it through the end of that subnet enumeration. So I'm not going to go through the whole thing. Don't think you need to see me spending 10 minutes adding by 4. But that's how we enumerate subnets. Hope this video was useful. Just practice going through enumerating subnets. Use the calculator to check your work. Make sure you're doing it correctly. Like I can take this one, 22.35.87.128/30. So I do have the correct number of usable hosts, only 2. My numbers check out, everything looks right. So feel free to use it. It's a good tool. So practice, make sure you're familiar with the concepts, but feel free to use the cheater calculator if you want to.